Okay, welcome guys. Today we're going to wrap up what we need to do for matrices, and we're going to learn what's called determinants of matrices. Determinants of matrices are very important because they're going to help you find inverses of certain matrices, and they're also going to help you find the area of any triangle. And that's pretty cool, actually. We know how to find the area of a triangle like that, where you have a base and you have a height. Area equals base times height divided by 2. But if I were to give you a triangle like this, that's a horrible triangle, but if it was like this, and I don't have a height, that's not a 90-degree angle, how do we find the height there? What do we do? Well, this is one way to do it. Another way to do it is by using something called the law of sines, which you will learn when you take trigonometry. But for today, we're going to learn how to do determinants. And these determinants, like I said, are going to help you figure out how to find an inverse and also how to find the area of any triangle. We're going to be talking about 2 by 2 and 3 by 3 matrices. That's what we're going to find the determinants for. And it's very simple. It's just these procedures with matrices, you can confuse them a lot. It's very easy to confuse and mix them all together. So I would suggest strongly to practice and make sure you understand what the differences are. First of all, in a 2 by 2 matrix, okay, this is the original matrix, okay? So that matrix is going to equal this determinant. You multiply the A times the D, and you subtract it from C times B. Literally. That's it. Literally. Done. So for example, if I say find the determinant of 3, 5, negative 2, 8. The determinant here is going to be 24 minus a negative 10, so plus 10. That would equal 34. It's these two guys minus the product of these two guys. Literally, that's it. Okay? That's easy enough, right? That's how you find the determinant of a 2 by 2. Forever. It's not going to get more complicated than that for a 2 by 2. 3 by 3 has a different procedure. But for a 2 by 2, again, that's it. For a 2 by 2, that's it. You're done. Multiply A times D, multiply these guys, and then you subtract minus B times C. And you're done. Now, yes, sir. When I show you how to find the area of a triangle, that's how we will do it. Thank you. Now, for a 3 by 3 matrix, we have a 3 by 3 matrix here. This is our matrix. And our determinant is going to be set up like this. You have the matrix that you started with, okay? But this is a little bit of a trick. There's a much longer process to this. I'm not even going to teach you that process because I don't like it and I don't find it efficient. This is the best way to do it. So what you're going to do, guys, is you're going to write down your regular matrix that they gave you. And then you're going to take the first two columns, you're going to take the first two columns, and you're going to put it right side by side to that matrix. Okay? All right? So you're going to put that there, so fill it in, please. You're going to have your matrix, and then you're going to take the first two columns, you put them right next to the right side of the original matrix that you have. Now, what do you do from there? You have it all here. Please pay attention to the blue and the red. All right. Once you have this set up like this, guys, you're going to have 6 perfect diagonals that you're going to create. Start at the top left corner and just literally go straight down. So A1 times B2 times BC times C3. Then B1 times C2 times A3. Then C1 times A2 times B3. Then minus, because determinants, you subtract them. Now the blue side. Starting on the bottom left corner, go straight across, multiplying all those three numbers. That's this. Then multiplying across all three numbers. That's this. Then multiplying across all three numbers. You created 6 diagonals. Now it's the sum of the red minus the sum of the blue. That's your determinant for a 3 by 3. Yes, sir. Yes, you have to distribute this negative sign. Yes. But remember, you won't really distribute it because you're going to add these all together as one sum, sir. Yes, sir. Yes, sir. I don't understand what you just said, brother. Oh, no. He's asking, what about this row? Ignore it. Don't worry about it. Don't worry about it. You don't do anything with that row, sir. Thank you for asking, brother. Thank you for asking. Okay? Let me give you a real quick example. So I got a lot of examples here, but real quick. Let's just go 1, 2, 1, 3, 1, 2, 1, 0, 1. Just for ease. Okay? First thing I want to do is I'm going to take my first 2 columns. I'm going to put it right next to each other, right here. And now, I'm just going to do diagonals. 1 times 1 times 1 is 1. Plus 2 times 2 times 1 is, plus 1 times 3 times 0 is, done with that. Minus, now let's do these guys. Bottom left corner, 1 times 1 times 1 is, 0 times 2 times 1 is, 1 times 3 times 2 is, so it's going to be 5 minus 7, so my determinant equals negative 2. It's not that bad. It's not that bad at all. Actually quite simple, as long as you follow the procedures, gentlemen. You okay, my man? You okay? You sure? Okay. Let's do some practice then. All right. I'm nice, and I went ahead and gave you the formula here just in case you forgot. But when we're finding a determinant of a 2 by 2, remember, it's the product of these guys minus the product of these guys. So that's going to be minus a negative 2. So that answer's 17. Done. You're done. Done. It's over. Done. It's literally that easy. If you remember the formulas, gentlemen. Okay? Now, let's go ahead and look at the next one again. Give you the formulas right there. So the first thing I'm going to do, I'm going to take the first 2 rows, and I'm going to write them over here. Please try to be as neat as possible so you can line things up, so you can knock out the diagonals correctly. And then just do it like I do it, guys. It's so easy this way. Put a parentheses. So it's 1 times 4 times 2, 8. 0 times negative 1 times 3, 0. Negative 2 times 0 times 5, 0. Minus, parentheses, bottom left corner. 3 times 4 times negative 2, negative 24. Great. 5 times negative 1 times 1, and 2 times 0 times 0, 0. So my answer is going to be 8 minus negative 29. So that's 8 plus 29 is 37. That is my determinant, sir. Sirs. Does it make sense, guys? Awesome. Awesome. It's not too bad, right? Pretty easy? Good. Okay. So let us continue then. Find each determinant. Let's see. I got 15 minus 12. Bam. It's 3. Done. That's 0 minus 0. So that's 0. Done. Done. Here, 1, 0, 2, 4, 5, negative 1. 1 times 4 times 3 is 12. 0 times 6 times 5 is 0. 3 times 2 times negative 1 is negative 6. Minus 5 times 4 times 3 is 60. Negative 1 times 6 times 1 is negative 6. What? And 3 times 2 times 0 is plus 0. So I have 12 minus 6 is 6 minus 56, 4. So that's going to equal negative 48 is my determinant, gentlemen. Okay? So, does that make sense? Okay. Next, area of a triangle. You can find the area of a triangle by simply saying 1/2 of the determinant of A. Okay? But this is a little bit of a different kind of setup. You have to realize that this is a little bit of a different setup. You're going to be given a triangle, and a triangle has vertices, okay? It's vertex. It's where the corners are. All right, these are vertices. So x1, y1 is your first point of the vertex. x2, y2 is your second point. x3, y3 is your third point. So this is what you're going to do here, guys. Sorry, it's not x3, x3. Thank you, sir. It's y. Thank you. Oh, what did I do there? Okay, so now we're going to set up x1, y1, 1, x2, y2, 1, x3, y3, 1. That is exactly how you have to do it. Now, does it matter who's x1, y1? That's the good part. No, it doesn't really matter. Doesn't really matter. But what you cannot do is mix and match. You can't put x1 here and then y2 here because you want to. No. Whoever you choose to be x1, y1, and x2, y2, and x3, y3 must be in the same order. So literally to find the area, it's 1/2 of the determinant, where you set up this matrix A to find your determinant. Yes, sir? Yes, I'm sorry, yes. There's an absolute value because you can't have a negative determinant, but that is absolute value, so it must be positive. So, don't laugh at my little lake drawing here. I know it's not the best. But my point is, have you ever heard of those Coast Guard shows? Okay. And how they triangulate? Have you heard triangulation? Well, this isn't triangulation because you need trigonometry for that. But what this does do is, this can tell you the area of where someone's lost or how large of an area you need to look for, okay? When they say, oh, you know, we have someone stranded, they don't know exactly where that is. So they have coordinates that they literally, it's done by a computer, but this is what the computer's doing. And it calculates the area. And then once it has the area, then it can actually triangulate, and you can use trigonometry to find the angles and all sorts of other information. But if I want to find the area, okay, I'm looking for, let's say, a missing treasure. And we know that it's inside of this triangular area. I want to know the size of this area to know how long it's going to take me to search for this treasure. Well, first things first, label, 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 label. x1, y1, x2, y2, x3, y3. Now, your matrix. x1, y1, 1. x2, y2, 1. x3, y3, 1. Now you find your determinant. Why did I do that? Your determinant, you're taking these two, remember these two guys? And you're putting them immediately to the left. So I got 1, 3, 5, 8, 9, negative 1. Okay, 1 times 8 times 1 is 1. 3 times 1 times 9 is 27. 5 times 1 times 1 is negative 5. What? 8. Sorry, 8. Minus 9 times 8 times 1 is 72. Negative 1 times 1 times 1 is negative 1. And 1 times 5 times 3 is 15. So that's going to be 35 minus 5. So that's 30 minus 86. So that's a negative 56. But the absolute value of that is positive 56. And remember, when we're using determinants for area, it's the absolute value of the determinant. So my area is going to equal 1/2 of the absolute value of the determinant. So in this particular case, it's 1/2 of 56. So it's going to be 28 square feet. We're assuming that these are all in feet. They'll tell you the units to use. Sir?
You know the 2x2 version, would that be more like to figure out like the distance of a line?
A 2x2 cannot be used to find area.
Distance of a line.
Distance of a line is not going to be found by using a matrix. Distance of a line is the distance formula, which we have already learned, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. Sir, thank you. All right, next. Now, inverse. That's a different type of distance. That's distance of a moving using velocity. Distance is rate times time, how far you went. But when you're looking for a distance of a line or a segment, it's that formula that I had just said, sir. All right, so now I want to talk about inverse, guys. An inverse is when you literally invert something. For example, if I have y equals x, x equals y would be my inverse. Okay? When you invert it, you're pretty much just flipping things around. You're flipping it around. So let's say that we have matrix A, which is A, B, C, D. Here's the good news. If the determinant is 0, then A is a singular matrix, it's called, and has no inverse. So if I say find the inverse if possible, and you check the determinant and it's 0, you could say none. There is no inverse. Please don't put no solution. Just say no inverse. If it's anything other than 0, whether it's positive or negative, then there is an inverse. And you write the inverse like this guy, a to the negative 1. When you have a to the negative 1, or b to the negative 1, or c to the negative 1, that to the negative 1 means an inverse. Because let's think about that. Doesn't that equal 1 over x? That's the inverse. Okay? Okay, so this is the hard formula. This is the one hard formula. Not because it's tough, but just because a lot of people don't remember it. Okay, so let me explain what I got here. The inverse of any 2 by 2, we're only doing 2 by 2s. We're not going to do inverses of 3 by 3s. But the inverse of any 2 by 2 is 1 over the determinant of matrix A, not the absolute value, but just the determinant, whatever value it is, times the inverted matrix. Please check this out. See how I had AD? Well, now I have DA. So I invert those, okay? I put the A where the D is and the D where the A is, okay? Again, I put the A where the D is and the D where the A is. And then I multiply the C and the B by a negative. I don't move them at all. I just multiply it by a negative. And then why did I do this part here? Because I was reminding you what the determinant is. The determinant is AB minus CB or BC. Okay? So again, it's 1 divided by the determinant times an inverted matrix. The A and the D will switch spots, and you make the C and the B negatives. If they were already negatives, then you're going to make it a positive. If it was a positive, you're going to make it a negative. Does that make sense, guys? Okay, so find the inverse of matrix A, if any. Well, always first start with the determinant. You got -9 minus a -6. So this is going to be -3, so that's my determinant. And this is going to work because it's not 0. Now, what is the inverse of this matrix? It's going to be 1 over the determinant times the matrix inverted. So that means this 3 goes to where the -3 was. This -3 goes to where the 3 was. So 3, -3. And then I'm going to make, that's a positive, that's a negative, good. +1, -6, literally. Now, we know how to do this. Isn't this scalar multiplication? So what's -1/3 times 3? -1. -1/3 times -6? +2. -1/3 times 1? -1/3. And -1/3 times -3? Bam, done. That's my inverse. Does that make sense, gentlemen? We're good? Not bad, right? Last but not least. Okay, again, let's do a determinant. We got 8 minus 6, so that's 2. That's my determinant. Great. The inverse matrix of A to the -1, is going to equal 1 over the determinant of 2 times the inverted matrix here. So it's going to now be 2, -2, -3, 4. Why? Because I switched the A and the D, and I make the B and the C negative. So now it's scalar multiplication. 1/2 times 2 is 1. 1/2 times -2 is -1. 1/2 times -3 is -3 halves. And 1/2 times 4 is 2. Ding dong, the witch is gone. That's my inverse for a 2 by 2. Awesome. Thank you very much, guys. Yeah, we are golden. Thank you. Awesome. God bless you and have a great day.